Hello, Patch1Stripe TV replacement parts. Your number one source for quality, hard to find TV replacement parts. This video will be about checking components. Yes, we're going to be checking components on a power supply board. And what I'm going to demonstrate to you is the different components that's on here and how to test them. And you'll see some of my different test equipment that I use, some of the techniques that I use. And going forward, let's have a good time with it. Okay, first of all, when I come in, I have a problem with a power supply. I normally check the incoming line, which is here. And so I go from here to the fuses, and then I'll do rectifiers. I'll do the bridge rectifiers, which come in different packages. This is one, but it also could come in like four diodes. And you can construct a bridge rectifier like that. So this particular one is a different package, as we call it. And it's 4 rectifiers in one package. So let's go ahead and get started. I'm gonna, first of all, I'm gonna go ahead. I like to check all the fuses. As you can see, 0.6 ohms. That's good. And see, when you touch your leads together, this is always a good technique I use in industry and in commercial use for consumer electronics. I like to put my 2 leads together, and what this tells me is that my leads are good and that I'm getting a good reading here on the scale. So it's just a good thing to do, even if you're checking voltage or whatever, okay? So we're gonna test this fuse right here. And that's test good. I got 2 small fuses. That's good. That's good. So the fuses that I see in here so far are good. Now the next thing I like to test is my diodes. And like I said, that'll be your bridge rectifier. And something I know about this board, and it's a rule of thumb with me. Rectifiers, when they go bad, rectifiers blow fuses. I've seen it time and time again, so I'm pretty confident in saying that. Rectifier blow fuses when they go bad. Whether it's in a package like this that makes up a transistor, which would be a PNP or NPE, or NPN, that's 2 diodes. 2 diodes internally inside of there. So even when they go bad, like a voltage regulator or something like that, they blow fuses. So I just checked these fuses. These fuses are good. I'm gonna go on. So just for demonstration purposes, now I'm gonna switch the meter to the diode scale, and this is the symbol for diodes, and we're gonna check diodes or rectifiers. Okay, and what they do, they conduct one way. So you see, we're not getting a reading. Now watch, I switch the leads around, and we're getting a reading. So they conduct one way. When a diode conducts both ways, in most cases, it's bad. what I usually do when I run across a diode that tests both directions, I desoldered out the circuit just to be sure I'm getting a true reading. So there you go again. One direction is open. One direction is conducting. Okay? So here we go here. So sometime when I get to going and I'm confident and I'm fast, I'll do this. Okay, this is open, this open, this open, and this open. You know, I test them in one direction because normally when they go bad, they're reading in both directions when you switch the leads. So when I run across one on a fast test and I just get a open end, it's pretty much good. But you build your own confidence up in that and go with that. Now watch this one. You hear that? Look. It's conducting both ways. Right? So one thing, like I told you, I like to go ahead and I'm going to desolder at least one end of this diode to take it out of the circuit. And we'll retest it and see if we're getting a true reading. Look, open, conducting. See how I can trick you? This diode is good. Okay? Now, moving on, let's test some of these other diodes in here. Good. See this one conducting both ways, right? So I'll take it, I desolder it from the circuit, and we'll retest it. Okay, we're right here. Look, open, conducting. That diode is also good. And that's some of the things you're going to run across with diodes. So when you run across one that's reading both directions, just like this one, you have to follow through with your testing procedure. Don't get excited. You know, just follow through with your testing procedure because it may be a good diode. Excuse me. Excuse me. Open one direction, conduct in the other direction. Okay, so far we haven't found the culprit here. So we're going to continue on testing components. Not conducting, conducting. And it really don't take very long to go component level and check all these components on a board like this. Now here's my bridge rectifier, which is made up of 4 diodes. You actually have to switch your leads around. Okay, that one's good. That one's good. That one's good. And that one's good. All 4 diodes test out. Now, for me, I'm going to go ahead and test some of these other components. Okay, I'm gonna check the other side of this. Now I got a specialized piece of equipment that tests transistors and voltage regulators, and but I'm doing this with a voltage ohm meter just so you can see that just because you don't have all that specialized equipment, you can do this with a regular voltage ohm meter. If you know what your component is, you know what your component can do. Most components, a lot of them, you can test with this voltage ohm meter. Now, I'm going to turn this around here. And I'm going to hit these back here. Same, and these have 3 legs on them, as we call it. Because basically, it's 2 diodes, either pointed in or they pointed out. When I say pointed, the arrow pointing to the ring, pointing out, or they pointing in. And that makes your PNP or NPN transistor. That one didn't test consistently to my satisfaction. So after I go my rounds, I'm going to come back and test those out. Okay, so we'll mark these as to be retested. Okay, the next thing I like to do is I like to test my electrolytic capacitors. And I have a specialized piece of equipment for that, which is called a ESR meter. And what that is, an electronic series resistance tester. Well, sorry, equivalent series resistor tester. And what it does, it measures the resistance on a capacitor. And basically, I can test capacitors in the circuit quicker than I could pull them out and test them with the capacitor tester. And what we're going for is very low. As you can look at the scale, the green is what we're looking at to be good, a very low resistance level, because this is ohms and this capacitor value here. So you want the resistance to be low. And I'll give you a look at how I do that. See, it's very low. That's good. Very low. That's good. Very low. And that's good. Very low. That's good. And I could go on even with this this capacitor over here, which I'm gonna be sure we don't have a charge on it. Short it to ground. And I could test this one as well. See? And that's pretty much done. I mean, you have some smaller ones, but what I'm doing here, I'm kind of hitting the high spots, okay? That's pretty much what I'm doing. So let's put this to the side. And we're going to go back with the voltage ohm meter. I'm going to put it on ohms, and I'm going to test some of these transformers. Now, a transformer is made up of secondary side and your primary side. And a lot of times they either step down voltage or they increase voltage depending on the application. So this is one side here. See, and what we actually checking is the windings. And that's good. And here we're checking windings. And some of these capacitors, you got a primary side and then a secondary on the primary side, and then it may have a couple of secondary windings, just like this one here in particular. See? So then we go over here. Let's see what we got here. Okay, that's checking good. And that's checking good. So this is good. So the rest of these, let's go over here. And it's in your low voltage power supply section. We'll run across these pretty quick from the back. Primary and secondary. And we get really good readings. 0.3 ohms, 0.4 ohms, 0.3 ohms, 0.4 ohms, 0.4 ohms, there you go. Now see, you're not going to get a reading here because it shouldn't be. The calls run, the primary is separated from the secondary. And it's electronic magnetic flux that induce the voltage to the secondary side. Okay. So, and also what we have here is this particular device here. It's called an MOV for if you get a inline surge suppressor, a surge, and it's like a interrupter, because if you do get a surge, it'll take the surge to ground and it'll destroy this particular component here. And it's listed as sort of like a Z as far as the symbol, as you can see here. So what I'm going to do, I'm going to check it on diodes, because it's actually two diodes head to head. You see, we're not going to get a reading. I'm going to switch these leads around, and we're not going to get a reading. So this is good. And you could also just check out how it's configured on here. Like this one leg of the power, and this other one, this other side over here is it'll kind of, like I say, it'll interrupt if we have any kind of short circuit coming into this power supply board. Okay. So we could go ahead and put it on ohms, and we could test some resistors. Be sure you don't have an open resistor. And after all, you know, right now I'm just showing you how to identify different components and how to test them. Okay, now this particular resistor, the color code is blue, black, gray, and gold, and which is the tolerance on it, how tight the tolerance is on it. Okay, and you have to know your color codes. And what I got here is a card that I use. I've had this a long time. I have several of them, and this is how I learned how to test resistors from a kid. So we got blue, black, and I got silver. Okay, so that's 60 divided by 100 ohms. So this resistor should be 6 ohms, 0.6 ohms. Excuse me, 0.6 ohms. And there it is, fluctuating from 6 to 7. So you know this resistor is good. Now let's take this one here. This one here, gray, red, orange. And the tolerance is gold, but we just need the gray. We'll put this up here where you can see it. The gray, the red, and the orange. So 8, 2, 3 zeros, 82,000. So it's 82,000 ohms here on this particular resistor. There you go, 82.9 K ohms, which is 1,000 ohms. And basically, you know, I'll do one more for you. I'll do this one here, which is red, black, and black. Red being 2, and black being 0, and the other black being 0. Okay, so this is actually I'll let you look at it. This is actually a 20 ohm resistor here. Let's test it. Okay, I'm getting 0.2 ohms. Okay, now I'm going to do something just to verify this. I won't be sending you down the wrong path. You can have confidence in what you're doing as well as me. Let's see what we got. Okay, so red, black, and black. So really, by the third color, the third color is probably divided by is divided by, let's see, it should be 20. I mean, it's straightforward, but it's reading like 2 ohms. Because if it was divided by a number, it would have let me know that, like divided by 10, or, you see that, or divided by 100. But nope, it's 0.0, so it's 20 ohms. And I'm going to verify this. Just hang with me here. Yep. And as you can see, I verified it on this electronic toolbox amp, and it should be 20 amps. I mean 20 ohms, excuse me. Red, black, black, and then the gold. Should be 20 ohms. So this resistor is not reading 20 ohms, but it's not a problem. It's not a problem at all, because it's still it's measuring good, but it's measuring continuity, but it should be 20 ohms. Okay, so you never know, that could be causing a problem. Now here's another one, red, black, and black, and it's also 2 ohms. So the color code and the resistance is not matching up on these particular resistors here. So that is a problem. But it's not a problem. It may be a problem that's caused a failure to this board, because 2 ohms and 20 ohms, that's a substantial difference in resistance. Now, as I was checking this board, I ran across something, and what I ran across is, let's see if I can bring it up where you can see it. Let me see, where is it? See right there? Got a chip out of it. It's blowed out. So just digging into a problem and just keep going forward. Sometimes you just stumble up on a problem. And this is the problem right here, this IC right there. It's got a big chip out of it. I'm gonna kind of rotate it a little around a little bit. Maybe you could see with the light across it, little dimple right there in it. That's blowed out. So this is bad. So I'm gonna stop here for a minute because you remember I told you that these transistors were also, they wasn't testing good. So I'm gonna desolder all this stuff, and then we're gonna come back and we're gonna take a look at what we have. Okay, I just thought about something. I don't want to deprive you of seeing me work. Now, what I use is a Pace brand soldering station and desoldering station, and they really cool to have. You know, you don't have to deal with the wick, the soldering wick, and which, you know, you don't get rid of the wick because sometimes you need a desoldering wick. But this desoldering piece of equipment, it works pretty smooth and pretty efficient. So I'm desoldering these transistors here that was on that heat sink that we discussed. And we're gonna go over here and we're gonna desolder this IC right here. Watch how fast it takes me to do it when you have the right equipment for the right job. And it don't make quite the mess that some of these desoldering tools can make. So if you're gonna be in this business, you know, I just highly recommend getting the right tools for the right job. It'll definitely make you efficient. As far as what you're doing, okay? Let's see. Okay. Okay, look how quick I took this IC out. I'll put it up here where you can see it. And see this little chip knocked out of it. It's bad, it's blowed out of it. Okay, so I know it's bad. Next, we're gonna go over here to these transistors. While I'm here, to make it easier for myself as far as to reinstall it and everything, I'm just gonna go ahead and desolder the whole mount. I'm gonna add a little solder to it to get everything flowing. And sometimes that's necessary. See how that started flowing real good? Give it a time to go through and through. And come back and let this desolder machine do what it do. Like I say, sometimes a little extra solder really helps to see how clean that is, that came out. Give it a little chance to melt through and through. It takes most of the solder right on out. hit this one again. See if I get this solder out of here. Oh yeah, look at that. You see that? Okay, there it is. Okay. And what I'm going to do, I'm going to pull out, well, let's go back with the meter. Let's just see if we was getting a false reading. I'm going to put it back on diodes. And let's see. We'll rotate these leads. Look at that. Checking bad in the circuit. Out of the circuit. Testing good. So when you doing some component level testing, sometimes you got to take things all the way out the circuit, and you just don't hit on something and you're saying, oh, this is bad, and I haven't not did the work to be absolutely positively sure that this is bad. I'm gonna put this up to the camera close enough, and maybe you could see the PNP. Let's see what this one here. Yeah, these are PNPs because the arrows is turning in. I hope you can see it, but it's two diode signals turning inward. So that's basically your transistors, okay? So this is our problem here. And we got a partial number here, which may be all I need. And that is this this FSHA 700X, which I've seen this before. You know, I get my magnifying glass and stuff like that and get a closer look, and FSH, and it might be 1700, I think, something like that. But this component is bad, and it'll probably repair this board. Now, of course, you know, I got it from this area right here. I'm gonna want to double check all the components that's in the area to be sure like they're fine as well. This is another resistor. This is a resistor, and this is a rectifier here. It's open on one side, and it's conducting on the other side. And I go on and check all these capacitors and this blue capacitor here. Now, some of these, like these Mylar capacitors, like these red ones, some of these capacitors here, that's on the block style. Well, they have a value code on them, and sometimes the value, for example, might be 820K, and it has to be converted. And I found this I use an iPod, and it's called Electronic Toolbox, and they have several of them out there where they can convert that number into a microfarad or a picofarad number that you can understand and go ahead and test. I haven't committed that code to my mind because it just haven't been necessary with these apps that they have out there to be certain when you do have to decode the number that's on some of these capacitors. Like this one here is 103K. Okay, I'll give you an example of that. And then, okay, now, I don't know if you could see this. Pretty cool. Now I just go to capacitor. And it's a 3-number capacitor plus an alphabet. So that number was 103K. Look down here. It is a 0.01 microfarad capacitor. This capacitor here, right here. That's what it is. It'll give it to you in picofarad and nanofarads, okay? But it's a 0.01 microfarad. And you could test these things because capacitors, I mean, they cause issues as well. Okay, well, with that being said, and not just to go on and on rambling, I showed you how to test some key components on a power supply board. And wish you luck in the future. Learn to use your tools to the max. Whatever you got, use it to its fullest capability. Now, you know, some of these fluke meters, they do ohms and they also have capacitance built into it. So I'm a big fan of fluke meters, by the way, because of how they rate it. You know, you get too cheap of a meter, low rating, they can be very dangerous. So if you want to be in this game, you know, have the right equipment, have some good industrial type equipment to make the job easy and to be safe. And before I get off of here, I'm going to show you my paste desoldering station. That's it right there. You know, you set the temperature of your desoldering iron as well as your iron, as well as your soldering iron. And I love this stuff here for my tip cleaner. You know, it's Bose. And maybe I'll make a video about this paste soldering iron. So you'll know the ins and outs of that and maybe decide to try to find you one. And with that being said, hope you enjoyed this video. Subscribe. Give me a big thumbs up. Remember, Patch1Stripe.com. TV repair parts, your #1 source for quality, hard to find replacement parts. And with that being said, Glad you came back. But you know the deal. I got to go. See you.